hope you are doing well. So we have another question to do, and the question says that a turntable of mass m and radius r spins freely about the vertical axis at an initial angular velocity omega. So there is a disk, and that is moving like that with acceleration velocity omega. The moment of inertia of the turntable about the axis of rotation is half mr squared, that is given. A small body of mass m is dropped close to the edge of a turntable with a negligible initial velocity. So there was a table like moving like this, and some mass has been attached to the table. The body comes to rest relative to the turntable. It means that that mass has been stick to the table that was moving like that. What is the final angular velocity of the turntable? So earlier that table was moving with omega, but when that particle has been stick to it, what is the final velocity? So in these questions you must have learned in the translational motions, like whenever there is some body and its body collide with each other, the momentum remains the same, that is constant. So in this circular rotational also, the momentum of the body remains same. So we will use that principle, that the momentum, that is the mv. Now we will convert this formula, it will become I omega. So the momentum, that is L, will be equals to I omega, and the initial inertia and the final inertia we will calculate according to that. So inertia is, so L inertia 1 is half mr square. So L, we will not write L here, we will just do it directly. So I will be like this, I1, so half mr square omega will be equal to a nu I into nu omega. So the nu omega will be, suppose, omega 1, and nu I will be half m r square plus. So one inertia is of the disk and another of that body that has stuck to it. So it will be m will be smaller, r square. So this is the new inertia after this mass has been placed on it. So the omega will be omega 1. So now we will calculate this and we will find the omega 1 value. Okay. So it will be like half m r square omega equals to, I'll just take multiply this with 2 both, 1 by 2 mr square multiplying with 2 mr square with 2, it becomes omega 1. So this 2 and 2, all this can be cut off because it's the common thing, and r square is also common, so we have removed this. So we are left with the capital M omega equals to m plus 2m omega 1. So omega 1 is equals to, I will take this into the denominator, that is the m upon m plus 2m, okay, into omega. So we got this answer. So the new angular velocity will be this. So m upon 2m, this first A option is the right option because here is no other option is right. A is the right option. Now we will check the mark scheme, and the mark scheme says A is the right answer. So hope you understood this question. In these questions, what we have to do, we have to just equalize the conservation of momentum. We have to use conservation of momentum in rotational motion. So thank you for watching.